This is lecture 5 of CS47 section 1. Uh, Topic is assembler, linker and loader. Basically we'll be discussing a couple of concepts here. One is how the executables are generated, means the overall top level big picture we want to understand in that executable generation process. And then we'll discuss about assembler and assembler provided facilities. So assembler, in the assembler top subtopic, we'll be discussing how assembler generates machine codes or object codes. uh, and then we'll see, apart from generating object code, assembler also provides some facility to ease up assembly programming. We'll review them, and then we'll discuss linker and loader. We'll touch a little bit on that because this is mainly a topic in compiler design and operating systems, these two subjects. So I hope you'll be learning more on these topics in those classes. But today we'll just touch on that and have some overall concept of what they do. So, as a big picture, here let's start with the assembly source file. So, means a program written in assembly. Of course, there will be like high level programs, and then compiler picks up that and makes an convert that high level program into assembly level program. So, this discussion will be more starting from an assembly level program here. And also in a large software development, like no, there is not one source code, one single source code. There are multiple source code. It's owned by multiple people. It's a team owned project. So we generally call them as a module, but a module not necessarily be one single source file, but kind of loosely term as a multiple module. They interact with each other. It means multiple source file of implementations, right? So we have multiple high level source code. They are being individually compiled and converted into assembly, multiple assembly for a given software. And then each assembly is transformed into something called an object file through assembler. Okay, object file through assembler. So if you familiar with the C++ compiler, GNU, C, GCC, etc., there are options to actually generate object files, which is called .o files, if you are familiar with that process. So basically, you do a GCC or high level program. It is kind of an assembly level programming. Is generation is transparent to you in this process. But there are options, I believe, to also dump corresponding assembly program. But no one does it. No one does it. So what happens? So on fly, it generates an intermediate source file, assembly source file. Then assembler is invoked, very much transparent to user, and .o file is created. So for users, it becomes apparently like okay, it's kind of GCC bunch of options, and the source file, let's say sample.cc, and then object file is generated as a sample.o. So that's the thing. But the point is, underlying an assembler is called, an object file is generated. So for n source file, we got n object files out of the assembler. Then a linker, a tool, another tool like is invoked. Like for often, it is kind of again transparent to the user. Like GCC, that compiling system actually consists of compiler, assembler, and linkers. So it invokes the compiler, then invokes the assembler, then invokes the linker. Now linker job is to combine all this n different object file into one single executable. There are some challenges in that it try to solve, and not only that, it also picks up object code from standard libraries. Like what is meant by standard library is that, for example, if you recall in a high level program, we all have used printf, for example, or scanf, right? And I think in the Java also we have printf, println kind of a concept, but we don't implement that function, right? Printf is a function. If you look at the calling of the printf, it is practically you're calling a function, but we haven't implemented that, right? As an application developers, we simply include some header file like standard io.h or different whatever, it doesn't matter. We include some header file to grab the footprint of that function, and so that object file can be generated correctly with calling that printf function. But implementation of the function is somewhere in the standard library, right? There is some object code for the printf implementation, and it comes as a standard part of your operating system installation, right? That's the library. So linker looks at this object file and see, well, it use, let's say object 2 use printf, so it pulls up the corresponding object code from the library to combine with your program to make a complete executable. So executable has to be standalone in this process. Like, it has to have all the information, all the instruction, all the machine codes that is needed to be executed on a computing system. So it needs to pull out all the object file of your software program. You need to pull out all the object file that your program refers to, all the library functions refers to. You need to pull out that object code, combine them, and make an executable. So that's the big picture goes on here. Okay, when you type in simple GCC or source code to generate an executable, all these things happens in background, transparent to you, but these steps are there. So as we discussed, assembler produces single object file from single assembly source code. Object file contains mainly the machine instruction and bookkeeping information to stitch several modules. We'll elaborate on this part a little bit later. Source code can contain reference to a label, so that's why your cross reference are resolved at a linker level. What it means is that, let's say your source code contains something like printf, or your source code, that one source code 1, let's say, contains a reference to another function which is in source code 2. Okay, so when we are assembling, we are generating object code for source code 1. It does not have any idea of what that function is, or whatever, how it is implemented, where to call it, etc., because it is an unresolved function at that point. So linker has this global view. Linker has this global view that, well, object file 1 is referring to a function which is defined in object file 2, so it resolves all the references at that point. So assembler, if something is called outside the scope of this source file, it just keep it open for linker to resolve. Okay, so that's what the cross reference or unresolved at object file level means. Like, assembler doesn't touch it. If it is an external function is called, is maybe implemented in another module, it let linker to take over that resolve of unreferenced unresolved references. Now, object code with unresolved reference cannot be executed directly, so linker takes the multiple module, as I told, resolve the cross reference and write the machine code with all the reference resolved. So that's what, like, executable has to be standalone. It has to resolve all the functions, all the labels. In terms of assembly area, we call it label, we don't call it a function. We'll come up with that concept also later. But let's interchangeably use the function and label that two term. So it resolve the cross references, write the machine code with all reference resolved. Outcome is an executable which can be executed on a machine. Linker also takes like pre-assembled object code provided with a common functionality as a procedure calls or subroutines. Like pre-assembled object code here means all your library routines. That's what we mean here.